Hi everyone, thank you for joining after a heavy lunch. I do understand why you have joined the session after lunch. Can I take a guess? I wish you don't do that. We'll try. Okay, I think you wanted to pick something simple and an easy session after lunch, and hence you have picked this. And I totally agree with you. That is what we're going to give today. So we're going to showcase to you how simple it is to build a decoupled, event-driven architecture within Google Cloud, and how easy and simple to scale and build performance. We'll have few co-hosts with me and you'll see how, but we'll go with that. Okay, to wake you guys up a little bit, few riddles from my side, brought to you by Duet AI. What has a lot of holes but can hold water? Good job, okay. Okay, let's start with the easy one, right? The answer is sponge. Okay, what has a lot of keys but cannot open a door? Okay, you guys, these are all the first things that DRDI told me, so put it in here, make it easy. Next one, what has a lot of events that you cannot attend? Not a DRDI thing. Tell me. What? Okay. Eventarc. Okay, that was my made-up thing. Hopefully it was okay. So yes, it can be PubSub or Eventarc, which has a lot of events, but you cannot attend. Let's get started. I am Kavitha Gowda. I am the PM lead for the orchestration products here at Google Cloud, and I kind of lead the Eventarc, workflows, tasks, and scheduler. Today, you'll be joined. Two data architects from ANZ Bank are going to join me, and you'll see how. And you can connect to me at LinkedIn using the QR code. And this is to stay connected if you have any questions later on, etc. And anytime you're welcome to get connected. Awesome. Let's first jump into ANZ Bank's success story. We are very thankful to our customer ANZ, who has graciously agreed to bring their story to you. ANZ has used Google Cloud products to catapult their online banking services to 10x. They relied on event-driven architecture and Google Cloud products like Eventarc, PubSub, and serverless platforms to build their online platform with high scale and performance. Without much ado, let's welcome our two speakers back there. There you go.
Hello, how's it going?
Sorry, that was a practical joke. They're going to join us through recording here.
ANZ has been leveraging the Google Cloud platform to build its event-driven architecture. We are headquartered here in Melbourne, Australia. We are one of the 4 largest banks in the ANZ region and proud to be one of the 25 largest banks in the world in terms of market capitalization.
Sorry. So we have been joined by 2 data architects. They're from Australia and they couldn't be here with us. So they have sent these slides and the recording. And any questions to them you can ask for me. And if I cannot answer, I'll definitely get the answers for you online or through your emails. Sounds good? Let's get started.
Exactly is ANZ Plus. Simply speaking, ANZ Plus is our new digital retail banking platform designed to help improve the financial well-being of our customers. Now, to deliver this proposition, ANZX is building this digital retail banking platform heavily leveraging Google Cloud. And it is on GCP that the event-driven architecture in ANZX plays a critical role in arming our customers as well as systems with accurate and timely information and insights. Now, let me hand it over to Sad so he can launch straight into discussing how we do EDA at ANZX.
Thanks, Trey, and hello, everyone. I'm excited to talk about our adoption of event-driven architecture in ANZX. So let's start by looking at some of the key objectives we have in mind. We have been heavily involved in designing and implementing event-driven architecture within our enterprise to meet our strategic goals, as well as to make ANZ Plus a successful offering for our customers. With event-driven architecture, we are able to deliver real-time use cases, which is a fundamental requirement for any digital bank, as you can imagine. Access to timely data and insights is paramount for not only our customers but our staff as well. As such, we are looking at opportunities to shave off even a slightest bit of latency where possible. For example, we utilize PubSub and Eventarc to deliver events in real time to our consumers instead of them periodically polling us. As you can imagine, banking is inherently a complex domain with many subsystems and even more integrated set of integrations. In order to move fast and deliver value quickly and fail gracefully, it is pertinent to design loosely coupled and highly cohesive system, which is exactly what EDA helps us realize. As we are powered by Google Cloud Platform, we take every opportunity to adopt and adapt exponential technologies and patterns to build a robust and future-proof system architecture. To that end, Kappa architecture help us streamline our data processing pipelines and avoid inefficient two-speed processing of our data. That is, we utilize same stream processing pipelines to realize our operational as well as analytical demands. Now let's have a look at our AZX EDA implementation. So this slide presents a bird's eye view of our event-driven architecture implementation. Our messaging platform is underpinned by Google's native services, that is PubSub and Eventarc. As you can observe in this diagram, in the center, we have PubSub and Eventarc. They play a central role to enable messaging between various producers and consumers. Further to this, we employ the use of cloud event specification, which is great for us due to the fact that it is also a first-class citizen in Google's own eventing ecosystem. On top of the picture, there is an array of business services actively interacting with the messaging platform. These could be our business services deployed on Cloud Run or Cloud Function, or even our back-end stream processing pipelines in Dataflow, for example. Additionally, our eventing platform also supplies real-time information to our digital banking mobile app, which is what you observe on the right. Apart from these two, we have a range of producers and consumers in shape of our core banking systems deployed on premises as well as SaaS vendors. Finally, in keeping up with the theme of adopting the latest and greatest in exponential technologies, we are actively implementing the data mesh framework within the enterprise. EDA is a key contributing partner to our data mesh strategy by allowing us to build data products using events and hosting them on BigQuery for future consumption. Now, Shri will discuss some of the key components and the metrics of our EDA implementation. Over to you, Shri.
Thank you, Sad. All right, let's look at some of the key features of our EDA implementation. As we mentioned earlier, our messaging platform comprises predominantly of Eventarc and PubSub, and especially PubSub is something that we consume in Anger a lot. As you can observe that we have over 2,000 topics deployed in our environments that funnel over 50 million messages per day. PubSub is really great for us as it's massively scalable and can easily handle our current volume metrics, but also support our future growth demands. Another great aspect of PubSub is that it supports both pull as well as a push model. Now, in the latter, or the push model, for example, we are using BigQuery push subscriptions to directly relay data into BigQuery. Eventarc is another service that we are now actively starting to consume to build our eventing pipelines. One of the main benefits that Eventarc provides is the abstracted infrastructure layer. That is, we don't need to manage the underlying infra at all. It's all managed for us. The great advantage is its ability to asynchronously deliver events to serverless components such as Cloud Run. Now, we have a lot of services deployed in Cloud Run, which in many cases require access to events, and Eventarc seamlessly delivers these events to Cloud Run. One of the key elements of our EDA implementation is our use of cloud events. If you don't know what cloud events are, Cloud Events is an open source specification for consistently describing event data. And our use of Cloud Events has also allowed us now to build a lot of common libraries that have become part and parcel of our eventing pipelines. For those who are interested in learning more about Cloud Events, feel free to Google for it or visit cloudevents.io and you'll come across heaps of beneficial literature on it. All right, now let's look at an actual implementation of a campaign that we went live with recently. The feature was called Refer a Friend, or for short, RAF, and the key aspect about its implementation was that it heavily utilized event-driven flows. Now, as you can see in the below wireframes, Refer a Friend is a feature of the ANZ Plus app that enables existing customers to invite their friends to join the bank. The friends then need to complete a series of checklists or a checklist of steps or items, such as they need to join the bank, they need to create a savings goal, and make at least 3 card purchases. When these conditions are met, both the referrer and the friend or the recipient receive a monetary reward from the bank. All right, in the next slide, we have a diagram that you're seeing, and it's a significantly cut down and a simplified version of the actual implementation architecture of Refer a Friend. Let's try and look at the architecture now at a very high level. The various actions performed by both the parties, that is the referrer and the recipient, results in events being emitted out. For example, when the recipient joins the bank, our origination system is going to emit an origination completed event. Similarly, when they create a savings goal, the accounting system emits a goal created event, so on and so forth. All these events then flow through into our Google powered messaging platform to eventually get delivered to our rewards tracker service on Cloud Run for further processing and reward fulfillment. Now that you all are familiar with the key concepts of RAF, let's together build our very own event-driven application in under 5 minutes, simulating the RAF use case.
Now that you all are familiar with the RAF concepts, let's build our very own event-driven application in under 5 minutes, simulating the RAF use case which Sri has just explained in the previous slide. Here's how the demo works. We have a fake publisher service deployed on a Cloud Run, and its job is to publish synthetic events into our messaging platform, which we will set up together shortly. These events then are delivered to a dummy reward service via Eventarc. This reward service will manage its state in Spanner database to keep track of all the incoming events and assesses if all the required events have arrived so that it can dispense the reward. The way it will work is that I will invite Shri to join the bank via ANZ Plus mobile app. When the invitation is accepted by Shri, then the fake publisher will generate an event called invitation accepted, which will flow through to the reward service via the pipeline which we will set up. Subsequently, Shri will download the mobile app and perform the required actions, such as complete onboarding, set up a savings goal, perform 3 transactions. With the completion of these steps, additional relevant synthetic events will be generated and delivered to the reward service, as you can see on the screen. Okay. When the reward service observes that all the events have arrived, it will mark the completion of reward by generating an event called reward completed to the same messaging platform. In addition, we will also set up a subscription to the BigQuery database table to store all the events. This is somewhat recent release from the Google, whereby you can just set a subscription and point it to a topic and to the BigQuery database table. All the events on the topic then will be stored into the BigQuery table. This comes in very handy in the demo because we can quickly verify if a particular event has landed or not. And in practice, it is very good tool to make any reporting and analytics based on the events your systems are publishing. Without further ado, let's get to the demo. Okay, so what you see on my screen is a Google Cloud Console, and here's the list of Cloud Run services which we have built and deployed already so that we can focus on the meaty bits, that is building and deploying our eventing pipeline in under 5 minutes. So these are the services which you saw on the previous slides as well. So this is Fake Event Publisher, that is CN Event Faker, and Fake Reward Tracking Service, which is CN Reward Tracker. So as part of our eventing pipeline, we will create a PubSub topic and an Eventarc trigger, which will subscribe to the topic we will create. And this Fake Event Publisher will publish event on the this new topic we will create, and Eventarc trigger will subscribe to this topic and deliver all the events to the CN Reward Tracking Service. Okay, so for simplicity's sake, we are creating a single topic for this demo. However, in practice, we have got topics aligned to the bounded context following domain-driven design principles. To provision this infrastructure for this eventing pipeline, we will run a series of gcloud commands that I have stored in a shell script. However, in practice, we use Terraform modules. So let's have a quick look at our shell script. Okay, so as you can notice, there are a set of environment variables declared on top of this shell script. This is some basic hygiene practice. So these are the variables we will be using in the gcloud commands on this shell script. So the first gcloud command is the gcloud pubsub topic create. It will create the topic cloudnext.demo, which we were talking about earlier. And then the next one is gcloud Eventarc trigger, which will create an Eventarc trigger for us. And it will deliver the events to this PubSub topic, which we are just creating. If you notice what I'm highlighting. And we are also configuring it to deliver all the events to the cloud run service, which is CN Reward Tracker service, which you saw on the previous page. In addition, we are also creating a BigQuery push subscription, which is somewhat recent release from Google, whereby you can configure a topic to write all the events to a BigQuery table. So this will come quite handy in this demo. We can confirm that if a particular event has arrived or not. In practice, this BigQuery table is a very powerful when you want to build your reporting analytics based on the events that your systems are publishing. Okay, so without further ado, let's run this shell script. Fingers crossed, hopefully it will provision our infrastructure very soon. And once that's done, we will go to Google Cloud Console and confirm if the required infrastructure is created or not. Okay, cool. Looks like it has already created the topic. Now it's creating trigger. Let's go to our Cloud Console and see if that topic is created. Nice. And now let's see if the Eventarc trigger is created. We're still waiting. Oh, cool. Okay. So this Eventarc trigger is created and it is going to subscribe to this cloudnext.demo and is going to deliver the events to our reward tracking service. Awesome. Okay. The shell script is completed as well. So that means the BigQuery subscription is created as well. So now our eventing pipeline is ready to deliver the events end to end. So let's publish some events, shall we? So for that purpose, we have created this mini website to generate the synthetic events. It will interact with the fake event publisher to publish the events. So this is the website. So here you notice there are 4 buttons. First one is accept and invite, open account, create goal, and make 3 card purchases. So let's assume I have already invited my best friend Shrey to join the bank, and now invite by clicking on this button. So once you click on this button, in the background, it will generate an event. So let's quickly see what's happening in the Cloud Run. Okay. So let's have a look at invitation accepted. This is the most recent one. Please ignore the previous log as I was actually testing this before. And now let's have a look at it. It has landed in the BigQuery subscription as well. Yes, invitation accepted is landed. That's great. Okay, so the next step, let's go back to our website. Oh, you can see that it is text, so this step is completed. So let's go to the next step, opening an account. So while it is doing that, let's see how quickly it arrives in the BigQuery. Awesome. Okay, account opened event has arrived as well. So the account is opened, the second event has arrived as well. So now let's create a goal. Okay, similarly, we will confirm that in the BigQuery. Yes, goal created. And right, nice. So the goal created event has arrived as well. So the last bit, make 3 cart purchases. By clicking this button, we are doing our last step. Right, transaction created event has already arrived, and we also notice there's a reward completed. Because our reward tracking service realized that all the events have arrived, so it has published the reward completed event as expected. Wow, congratulations, it's all done. So thanks, Ray, and now we will be both receiving a reward. Great.
Awesome. Hopefully this was really helpful for you guys. And we are really grateful to ANZ to have showcased the enterprise scenario. I think one of those slides that had the performance and latency, I think it'll help you guys in realizing how much scale and performance you can get out of Google Cloud eventing products. Without much ado, let's go on to our next slide that we're going to do another demo here. So this demo is to orchestrate your service fast and easy. You did see that ANZ used Cloud Run and then tried to orchestrate few events and waited for an action to take some kind of a reward. We want to showcase something similar, but how you would do all of this in a serverless manner without writing a code, right? No code or a low code scenario with Cloud Workflows. How many of you guys have used Cloud Workflows? Okay, few hands. So Cloud Workflow is a serverless product which orchestrates and automates your business processes within the Google Cloud ecosystem. It's used in data pipeline creation, your business processing. We also have seen that the platform admin using it to manage their Google Cloud using gcloud commands. And in the future, we're also going to release kubectl API commands in it so that you can orchestrate your GKE cluster and manage them also without writing any code. And it's all YAML based at this point. How are we going to realize this in this demo is we are going to create an e-commerce website. We are a company, we are building e-commerce website. And whenever a user makes a purchase on the e-commerce website, we are going to add that order into cloud storage. And this can be anything, right? It can be your Firestore or another DB, Eventarc as a CDC event subscription to Firestore, or all of that events can be subscribed and then used to trigger workflows. And once the storage has been made, the Eventarc is going to pull the event and trigger the cloud workflows. And in cloud workflows, you're going to do some logic here. We have kind of tried to create some fake logic here to showcase this demo. Usually, you write into your BigQuery or the table for data analytics. You would store it into any kind of storage. Maybe in this case, we are using the storage system, so that's easier. And then we are also showcasing here a rewards API private endpoint. If there's more than 3 transactions, we are going to call the rewards API, which is going to give us some kind of a coupon, and then we are going to email. Some simple workflow here for you guys to showcase its capabilities within a few minutes here. So the rewards API is a private endpoint. I don't know if people use cloud workflows. This was one of the most asked feature to be able to call a private endpoint, and that is what we're releasing in Cloud Next. And you'll see many, many more good things in the next announcements in a few slides. Okay, let's get started with the demo here. What we're going to do with the demo initially is we're going to take you guys through how we build a YAML in the cloud workflow. And once we build, we'll deploy all those resources, and then we're going to take you guys through an e-commerce website. So let's get started here. And this is the cloud workflow console. And here what we're doing is we're reading an event and getting all the event information and storing it into the variables inside. So we are basically assigning, as you can see here, assign product name, number, customer name. These are some of the information we got from the event. Once we have it, we want to store somewhere, right? And to store, if it's a first time customer, you don't have the storage created for that customer. So you kind of do try an exception blocks and a known exception. In a known exception, we are going to create that profile if it does not exist. So it calls a create profile, customer profile, and this is a sub workflow. You can create sub workflows within workflows, and you can call other workflows. You can do all of those magics. All we are doing is creating some bucket here and creating a customer table. And this is the flow that happens only if the first time. And after that, what we are going to do is save the information into the bucket. And again, as I said, this can be any of your data storage system. And once you do that, we are going to go ahead and save information into BigQuery. This is, again, most of our customers we have seen do this, so we are just adding this for demo purposes. So here's a logic where you can now list all the purchases made by the customer and then make a condition. The condition here is if I see more than 3 items or equal to 3 items, we are going to do get rewards, go into the flow of get rewards, else we'll end this workflow. And in the get rewards, as I said, this is a private endpoint. It can be anything. It can be on your VM, or it can be a GKE private endpoint. We have enabled that, and I think if you're keen with VPCSC, this enables you to create that perimeter and then call services within your perimeter. And then that just gives you a coupon out, and bring the coupon in, and then send an email. Send an email is also a sub-workflow here. All it does is call SendGrid API, and the SendGrid API, you just send an email to the customer and do an HTTP post. And all of this reward steps goes only when you have made 3 purchases. If not, it just goes to an end. So it's that simple. So everything is in a YAML. You did a lot of things, what you would have done with your microservices and your other things within one simple YAML, and it's going to get more powerful as well. So workflow also has this visualization capability, which is at the native stage at this point, where it kind of helps you to realize what your workflow does, right? What's the next step, et cetera. Workflow can also do callbacks. Workflows can wait. It can poll. So it helps in your manual approval, and it integrates with events. It can wait for an event. Once the event is brought in, then it can start up again, or it'll call back and it'll wait for that event to occur. And in that case, maybe a human approval or something else, and it can trigger from there. Here you can see the graphics will help you to figure out what calls what. In our case, in a try block, it directly goes to a save, but it's to the bucket, and then BigQuery, et cetera. So this visualization is going to change in coming months, so stay connected with her. It's going to be much more easier to author your YAML. We are also integrating with the Duet AI, so all you have to say is, whatever I said so far in that demo slide, just type it in. It should be able to produce this for you. Now let's go ahead and create these resources in the gcloud command. And then I just want to pull together how easy it is to just call a gcloud command and create all the serverless resources. And they are serverless. It manages the execution. It also manages scale and performance for you. And we are here creating the bucket first. Once the bucket is done, we are going to create the workflows. So for a workflow, you need to provide a service account if you want to call all the other services, correct? So to call all the other services, the service account should have permissions. So we have gone ahead and created all of that before in hand, and make sure your service account, whatever services you're calling, it has permissions to it. So let's provide the service account that we have provided here to our gcloud command. All you have to do is workflows deploy, and then put the source as the demo YAML. The YAML can be stored in your CI/CD, and then you can automate all of this. Once done, you can see your YAML. So let's go ahead and now do Eventarc trigger. So Eventarc has direct integration with workflows. So all you are saying is, Eventarc, when there's this event, something happens in this bucket, please call the workflow with the information, and that's what it is. So filter based on your bucket, and then put your storage, and it should be able to create it. So it has a direct integration. And you'll see in the console that you can see the trigger right in the workflow console. Okie dokie. Next is the data set, and the BigQuery data set we are creating here, and that should be done. So that way we can create a table and add all the logs into the BigQuery. In the console, let's come in and type the workflow's name to see if the workflow exists. And you have various different filters you can use. And I'm just going to use the name here for the next demo. And you should be able to see the workflow. So as I said, we are not able to announce completely what we'll be bringing with respect to the entire visualization, as it's going to unfold in several different months. So we're going to put some announcements, so stay tuned. And just the bucket is created is what we are showcasing here. And then we'll go and look at the event triggers. So event triggers is really helpful. It's a very simple mechanism, right? Triggering is 1:1, where I'm listening to the GCP services. It has about 136 services, events for all the 136 services, and it has direct integration with many of the data stores of Google Cloud, which is going to come in handy. So in this case, we are just saying, hey, this is the trigger for cloud storage. Now let's go and make our first purchase. So let's buy, and let's see our workflow in action. So we create all of this in such a quick steps, and you can make your enterprise come to realization within a few minutes. So we are now seeing all the steps that the workflow took for this execution. It shows there's an exception there, because what we did have if there's no customer bucket, let's go create it. There's a try, fail, and then it has an exception catch to create the profile. And we also logged into it. You can do all the logs and all the standard things. And here you can see your event payload that came into your workflows as well. Let's quickly switch to our bucket and see if we can see the demo customer. Sorry, we gave a lame customer name. So the bucket has to be created in the customer name, and the name here is demo customer. Now it has that file. This is all done by workflow. It's just basically we're going through the workflow, and the BigQuery should also be able to do it. So now all of this, once all of it's done, we'll make 2 more purchases to see the reward things. So ideally, with your EDA, event-driven architecture, you can use many of the serverless products that Google provides, and it has a 1:1 integration with all of these products that helps you create an EDA, create your kappa pattern easily end-to-end without having to spend much time, and Google will take care of your scale and performance. So now I've made 2 purchases. You can see all of it here, and I think we're just going through and showcasing you that the workflows went and created this file as what we said. And now that all of these have been done, now we have that condition that is if you have made 3 purchases, you're going to get some coupon. And that should have triggered the get rewards and would have sent an email. Let's see if we got an email in a second here. So all of this should have triggered an email workflow, and ta-da, that's it. You got a coupon and a 50% off for your thing. So that's just a simple workflow demo that we just wanted to provide, and to showcase you how simple it is to put together with a low-code scenario. And at this point, workflow supports about 10K parallel executions, and we have a great announcement about it in just a second. So let's go quickly to some of the launches that we are making. So here's, if you want to take a snapshot, you can take. We're going to talk about each one of these in a second. And go talk about it. So these are some of the announcements that we have, which are going to land in next month or next 2 months. And post next 2 months, please follow our workflows, follow our roadmap for both Eventarc workflow and task and scheduler. A lot of it coming your way. Okay, so Eventarc is also going to support an internal HTTP endpoint. That is, this again is a VPC-SE for your security. Not only it can talk to cloud run functions and GKE and workflows, now it can call any endpoint that you provide, both internal and external. And it has many different GCP sources, 137, and then it has about 3,000 events through the logs and 26 direct integration, including our Firestore and Dataflow. Both of them are in public preview. We are going to go GA with them shortly in the next quarter. So next is the workflow, which I talked about, private invocation, public preview. And then this is something that workflow is going to improve a lot on. Today, what I showed you is workflow executed, and then you can go and see in the execution steps, what are the steps that it has, right? That is still not released. That's still in preview. That is what you're going to see next month. And we are going to improve a lot more on it. because it's not sufficient what we have today for you guys. So we're going to work a lot in bringing the parallel execution. You can step through the loop and see what happened, what are the variables that got passed. All of this advanced execution history and debugging are all coming. And definitely the CMEK support for your security for both workflows and Eventarc. So switching to task, task released easy task, easy, I don't know, how many use cloud tasks and scheduler here? Oh, wow, not many. It's just one or two there. Awesome. These are one of our very famous products used by almost all the large enterprises of Google Cloud. And we pass something called Easy Task. Now that it's easy to manage your queue, you provide all the information of the destination in the queue, so your HTTP request into it is going to be simple. Okay, so these are some of the roadmaps that are going to land. So as I said, for Eventarc, the sources are all going GA in the next quarter and this quarter. For workflow execution history, it's going to improve a lot in coming quarter, and we'll keep releasing it and making blogs and announcements on it. And we are also, so this is another announcement, workflow can have 5K parallel executions. That means you can have your 5K workflows running in parallel in a region. Now that can be expanded to 100K, or even we are trying to make it limitless. So we have this huge requirement from our customers wanting to run workflows, and we have seen many running parallelly hundreds of workflows in a minute. So it's used for batch, it's used for data pipelining, it's used for eventing, so many different cases. So these are some of them, and I think I've reached my time. And this is a Eventing Insider group sign up that we are, if you guys want to stay connected with us, there's a lot of new exciting things happening at Eventing with Google Cloud products. I cannot announce them as we are not delivering them in this next quarter. But there's super exciting things that I cannot fully talk about. But if you get to be an insider group, we're going to connect with you. You will be in the front seat driving some of those features and also using them and getting together with us on private previews, et cetera. Interested, please sign up here. And we're also taking some design partners. That means jointly we're going to design together. So enter the information. Cool. All the feedback here, as you guys already know. And thank you once again for attending the session and being with me, and hope it was simple and easy. Okay, now the claps. Thank you.